Hi, this is Paul. Today we're going to talk about 3D printing. It ain't dead, but it does smell funny. Let me get my tea. Earl Grey, of course. And no, that did not come from my RepRap Type A Series 1 machine. And that was part of the issue. About 3 years ago, MakerBot came out with the Replicator, which on Star Trek basically could make anything you want. So that set a pretty high bar for 3D printing. Now 3D printing had been around in commercial environments for more than 30 years. But those of you that know the story know how the FDM type machines came out and were targeted towards the home user. I like to think of myself as a small manufacturer, and that's the kind of solution that I need. I make a variety of parts. Some of these parts are for replacements on parts for pinball machines that are no longer obtainium, so we call them the unobtainable. One of those was a gun handle for the Batman Forever pinball machine. Molds were lost a long time ago, so basically went to go tackle making a new one of these. So the first thing I did was, one of the reasons that I got this Type A Series 1 machine is the size of the build space. I mean, it's almost it's 10 inches by 9 inches by a little bit more than a foot in the Z direction, which is perfect size for doing something like this. The problem with doing something like this on this machine, I mean, I started out with just a small test piece, and even the small, even on the small piece, like maybe 1 out of 5 test prints would start to warp and pull away from the print bed. Now I could go with a heated print bed. This one didn't originally come with that, but I can make one and upgrade it. That's part of the good things about having RepRap. But I've got basically a channel where the two pieces lock together, and if I go with a heated bed, I may not get the consistency in that channel without playing with the design quite a bit. So one of the things that I tried to do is build a raft so that would adhere. The part's still too big, kind of depending on the day and the temperatures to get it to adhere to the print bed like I would want. Now, when I started out with this part, another important part of 3D printing is the software that's needed for it. And in the last 3 years, it's evolved quite a bit. But even a year ago when I started this part, since it's an organic shape, it has a lot of little features, particularly on the inside. I didn't want to start the design from scratch. So I used David's scanning software to scan the part as the highest resolution that I could get at the time. And I still had issues. I mean, there were holes that needed to be filled. I was using an initial version of Mesh Mixer, which great tool, but I was still having trouble filling some of the holes. So basically, I had this put together and redesigned from SolidWorks, which both it and Fusion 360 now can do organic B-splines and can do a part that looks like this. So I was able to get a real good design put together. So I had to look at going to 3D print services. The issue with 3D print services is for these 3 parts, 2 sides and a trigger, I got quotes that were anywhere from a little over $350 to as much as $1,200 for basically a mix of ABS, PLA, and a couple of Palmers. Pretty much the same thing. I went with a company that I think has since been bought by UPS to print the first couple of ones. And in fact, one thing that's nice about printing and printing one off is I was able to do clear for a guy that wanted to light the inside of the gun handle, and was able to do that with a medical grade Palmer. They ended up, the cost of the part was about $500. And one of the things that I ran into, and you're going to do this when you have new suppliers, although it's matured since then, and this is the way that I'd say that it kind of still smells funny, is I was very specific on, just ship this 3-day, put it in a box, it's really light, it's going to cost about, $10 to ship it that way. They overnighted it, which ended up costing $100. Result of that was we had a nice discussion, and they've since changed their business process. Another piece that I wanted to go with is this great new company that started out of Houston they make a product called Gigabot, which is basically a huge monster rep wrap. So I've had to print this first one. Now, these are the issues that you run into. I meant it was well communicated, print this in black. I got it in gray, it's missing a part, and here's one of those things that you run into. This was printed in an environment at 2 different times, slightly different environmental conditions, and the parts don't line up. And so, in fact, one part is probably about 3/32 bigger than the other part. So right now they're reprinting it, getting in the right color. I've asked them to print them on the bed at the same time. We'll see if we get a little bit more consistency in our site. But that was the reason that I had to go with some of these print services. This was done on a Stratasys, I think it was the Fortus 400. It might have been the 200, but it was 2 different companies that I used. The issue there is, you're paying for what you get. They're going to print this, and 99% of the time it's going to print right the first time. They're going to be able to print with a dual head. They're going to be able to print a washable support material. But the most important thing is it's printed inside a temperature-controlled oven. That's going to keep the part consistent, and that's what you want. And that's not what you're going to be able to get on a rep wrap type of machine. Of course, it's going to cost more, and here's where the cost is. It's kind of like the old HP printer cartridge issue. You want to be able to control a consistent feed on those machines. They've got a chip in it. They try to go with product that is designed specifically for that printer, which means, the roll that I pay for on this type of machine that could be $25 to $40, on that machine it's going to be $300. So you've got that. You've got a higher cost of a machine that costs anywhere from $100,000 to $200,000. That's a lot of capital to recover. That gets reflected in the part. That's something that needs to change, and I'm starting to see some other printers come out in the lower end range. I know that both Stratasys and 3D Systems had printers in kind of the 20,000, 30,000 range. They've kind of been moving away from that and going back into the high-end manufacturing. But there's a gap there for a printer. I mean, you can buy, I think it's called U-Print from Stratasys. You can get a new one for just under $20,000. You can find them on eBay for around $7,000, depends on if they got the wash station or not. But again, the issue is, as soon as you buy that, you're paying $300 a cartridge for a part like this, and I may get 3 stretching it to get a piece out of there, plus the cost of the equipment and then the ongoing maintenance. So that's kind of where we are with those pieces. Another issue that you run into that people don't realize is, they look at 3D printing, they say it's $25 a roll for a piece of plastic. Why does your part cost so much? Well, this is a dice roller for a college. The guy sent me the STL file to print it, and I have this right here takes a little over 24 hours on this printer to print, and it's not at the highest of resolutions. I think I printed this one around 150, but as you look at the print, you can see where I can't believe that the head would have slipped on the feed. I mean, I've never had that happen before in more than 2 years of printing, but something slipped. I'm guessing it might have been I might have hit the print bed or something. But it definitely slipped at that point. The other thing is if you look up here, I've got some inconsistency on the material, which could be the material has been sitting out on the printer. Yeah, I was a little lazy, sorry, but it could have absorbed some moisture, or it if you look here, it got to this area right here. It could just be there was a problem with the material, not sure what happened, but that's 24 hours of work, has to go away, and you get to start over again. So it's things like that that impact the cost of 3D printing. Does that mean that 3D printing is dead? Certainly not. I mean, I've got parts here that were customizations for a pinball machine. I've got this part here which now can restore some of those 2,000 games that are floating around out there that are missing their handle. And hopefully, as time goes on, we're going to get a printer that is kind of for the lower end manufacturer. And let me go downstairs. I'll show you a product. Okay, let's talk about a commercial product that uses 3D printing in its production. This is the America's Most Haunted Pinball Machine. The first run pinball made by a new manufacturer called Spooky Pinball. And what I want to point out to you is in this game, there's parts like a door to the dungeon, the ghost, the ball lane guides, and there's an elevator and a screw type setting underneath it that raises and lowers the elevator. All of those items are 3D printed items for this game, printed in ABS on a RepRap type of printer. So there were 150 of these produced. The cool thing about this is when you purchase this game, you get all of the print files. So if a part ever breaks, you can either print it on your own or just get access to somebody local and get your game back up and running. So 3D printing in this case is real and viable.